So let's talk quantitation. You know, one of the most popular things we do in our LCGC bootcamp is to build calibration curves. We do a 4-point external standard for HPLC, we do a 3-point internal standard for GC, and that gives our participants real hands-on experience in building calibration curves. Now here's the thing that's always struck me as odd. After teaching this stuff for 25 years to professionals from big companies, I find that about half the people actually don't use their data system to do their calibrations. They take their data, and then they type it into Excel, and then they use Excel to do the quantitation. Now you can do that, but you're asking for a lot of extra work and transcription errors. Let me show you how to do it inside the software. Every software package out there that's used for chromatography has this capability. I'm going to show you my version of it. This is the Agilent ChemStation B.0403, but let me show you how to build a 4-point calibration. So this is a series of standards that have already been run on this instrument, and they were caffeine standards, and we have them in microgram per mil or part per million. And what they are is we have a 50, 100, 250, and 500 microgram per milliliter standard. So the way this works is, step one, actually run the standards. So go to lab, run your 50, 100, 250, 500, collect that data, and then we're going to go into data analysis in order to do something with the data. So now I'm in the data analysis part of the software. The first thing we're going to do is we're going to load the lowest level standard. Now you can start at any point, high, low, medium, but I always say start low and go high. It's a little more organized if you do it this way. So here is my low-level standard. There's only one peak. It's a caffeine standard, and it's there at 1.25 minutes. So now I'm going to go to the software, and I'm going to say calibration, new calibration table. Always choose automatic setup, because what the computer needs to know is the retention time, the area, and the amount. Well, you're the computer. You know the retention time and the area. Don't make me type it in again. Just get it from the chromatogram. I could type in a default amount. I'll leave it blank for now, but here I'll just say OK. Overwrite existing, I'll say yes. And it says, hey, I found 2 peaks. This first one is not really a peak. And the second one is my caffeine. So that second one, I'm going to type in the amount, so 50 microgram per mil. I know that because we made the standard, so we know what's in it. We're going to give it the name, caffeine, and that's all we need to do for a single point calibration. If I say OK, notice it's going to say, hey, I notice you got some lines with 0 amounts. You want me to throw them away? Yeah, of course I do. I don't care about that solvent front, so I'm going to say yes. Okay, so I've now completed a single point calibration for caffeine. That wasn't so hard, was it? So now let's add a couple more points. Let's load the 100 levels, 100 ppm standard. So there's our 100. So I go up to calibration, and I don't want a new calibration table. I already have one. I just want to add a level. So I'm going to add a level, and this is 100 ppm or microgram per mil. And now I have a 2-point calibration. Hey, look at that correlation coefficient of 1.0. Well, it's only 2 points, so don't be so impressed. Let's keep going. We're going to load the next signal, which is the 250. I'll show you a little shortcut. This icon means add a level. So we're going to add the level, call this 250. And then finally, the last standard of 500. Let's load the standard. Let's add a level. Let's type in the amount and say OK. So there you have it. I just built a 4-point calibration curve in, I don't know, what was that, like 2 minutes? Plus me blabbing on along. You could do it in even less than that. If we take a look at the equation of the line, remember y equals mx plus b. Y is the area, m is the slope, x is the amount, and b is the y-intercept. So it calculated, using linear regression, calculated the equation of the line, and notice the correlation coefficient. That's real, 1.0000. This is LC. Auto samplers in LC are really, really good, excellent precision, and because of that, we get excellent linearity. So now that I've done this, I can use that calibration curve to quantify caffeine in any unknown sample. So these are real samples written that were run by one of our customer batches, Alicia, Michelle, and Joe. They must have been really good because I'm using their data for the world to see. And let me load one of their samples. They actually looked at a soft drink. And if we take a look at that, we're going to go ahead and load it. And if I say, just show me what the report would look like, print to the screen, we can see a beautiful chromatogram, a caffeine peak, and then on the, on that page, it gives me an amount of 116.4 microgram per milliliter. So I just build a 4-point calibration curve and use it to identify and quantify caffeine in a total unknown in just a matter of minutes. You can do that yourself. So hopefully this helps. If you have more things that you'd like to see demonstrated, make a comment in the comment section. We're happy to take requests and come back and learn some more fun chromatography.